when first slide as to intro about the hot problem in the world now with the greenhouse gas, and also here this figure shows the start greenhouse gas by some sector, and nowadays the concentration of greenhouse gas increase very fast, and in this figure, let's show the relation with the global temperature and one of greenhouse gas, the carbon dioxide concentration. So nowadays for decrease the concentration of greenhouse gas, we can use the reforming reaction for two greenhouse gas, the carbon dioxide and methane, and the product is the syngas. With the syngas, we have too many applications for liquefied gas synthesis, and also used for electric or synthesis industrial. And depend on the ratio of carbon monoxide and hydrogen, we can harvest too many products like fuel, like ammonia, ethanol, dimethylene ether, and it's all the products have a very important for the synthesis industrial. And here and for the reforming process, nowadays we have two types process. One they call it the stream reforming process. In this process, they add the natural gas, carbon dioxide, and also the water for this reaction, and the ratio of hydrogen and CO is depend on the process is between 1:1 or 3:1. With another process, they call it a drying process, and one of them is they use a catalyst with a high temperature. And here I would like to show some main reaction with this catalyst process. And you can see here is a byproduct here. They have a carbon dioxide. They have a carbon deposit on the surface of catalyst, and by this process, we have a high conversion, high surface area of reaction, and low byproduct. But we need to use a very high temperature, and also the catalysts have a dielectric by carbon deposit, and in this process we use a high specific energy. Another drying process, we use a plasma for the reforming process, and here I would like to show some main reaction inside the plasma process. With the plasma process, they have generated many radicals inside the plasma zone. And here you can see with all the reaction here don't have a don't generate the carbon, and also the temperature is low, high flux, and also the high selectivity. But but in plasma process, it have a low conversion and very high the byproduct. So for increase combustion in the plasma process, we would like we have combined the plasma process with the catalyst, and we try to reduce the activation energy for the plasma process. And also here is our experiment schematic. And in this slide, I put so to the how to prepare our experiment. We use the zeolite as a catalyst, add to inside the plasma reactor, and the carbon dioxide and the methane have mixed well before go to the reaction zone, and the product gas have analyzed by gas chromatography. And here is a standard condition used for our reactor. And in the researcher purpose, we have investigate the effects of voltage gas applied to the plasma, effects of total flow rate, frequency applied to plasma, and also the concentration of carbon dioxide and methane on the reforming reaction. And here we go is the results. With first case, we have we have effects of frequency applied to the plasma to the plasma, and here this figure shows the conversion of carbon dioxide and methane. As the figure so that with the increased voltage and the frequency applied to the plasma, the conversion of carbon dioxide and methane is increased, because we add more energy to generate the reticle inside the plasma zone. So that's why the conversion of most gas is increased. And here this figure have show the carbon monoxide selectivity and hydrogen selectivity. Here you can see the plasma with the low voltage 2 kV is the no don't have a reaction, but when we increase from 2 to 4, the selectivity is increased too fast, very fast, and keep the stable from 2 to 12 kV. Another case we have research about the effects of the concentration of carbon dioxide and CH4, and here you can see by increase concentration of the carbon dioxide and CH4, the conversion of carbon dioxide and methane is decreased. The reason is here we use by the keep the same total flow rate, we add more we add the nitrogen gas inside the plasma zone, so it have with the high concentration of nitrogen gas, it have a high radical for the reaction take place. So that's why with the high nitrogen concentration have the high conversion. And here for the selectivity of CO, you can see it have a maximum at 80%. test concentration, and for the hydrogen, it's the gas maximum at 60%. With another case, we have effect of ratio of carbon dioxide and CH4. In this case, we can see by increase the ratio of carbon dioxide to CH4, the conversion of carbon dioxide is decreased, but the conversion of CH4 is increased. And here we show that the selectivity of CO in this case, and you can see the selectivity of CO is gas maximum with the 4/1, and also because the hydrogen dielectric is very complex, so that's why here we can see the selectivity of hydrogen is not follow function. And another case, we change the total flow rate. We change the total flow rate from 0.3 liter per minute to 1.6 liter per minute, and with the increase total flow rate, the conversion of carbon dioxide and CH4 is decreased. But the selectivity of carbon monoxide and hydrogen is almost stable. So let me summarize our research. First, we study the carbon dioxide reforming of methane by the combined process of catalyst and plasma, and we investigate the effects of different process conditions, such as the voltage and frequency applied to plasma, ratio of carbon dioxide and methane, and total flow rate test before reaction. And we use the zeolite particle in the combined process as have increased the effects of reforming carbon dioxide and CH4 reaction. And as the voltage and frequency applied to plasma increase, the conversion of carbon dioxide and CH4 is increased. And also the selectivity of carbon monoxide and hydrogen increased at 20% plasma gas is nitrogen we use by the increase in the voltage applied to plasma. So that's all my presentation. So thank you for attention.